Welcome to the next video of Force and Laws of Motion, Conservation of Momentum. Momentum is a property of a moving object. Momentum is the product of mass into velocity of a moving object. Now, let us consider that there are two masses A and B with mass m1 and m2. Let these balls move with an initial velocity of u1 and u2. So the ball is continuously moving in the same direction along a straight line. Let there be no external unbalanced force acting on the balls. Now at some instant, the initial velocity of ball A, that is u1, is greater than u2. Then what will happen? Yes, the balls will collide with each other. So the collision will last for time t, and during the collision, ball A is exerting a force AB on ball B and ball B is exerting a force BA on ball A. Now after collision, what will happen? The velocities of the ball will change. So the velocity of ball A changes to V1 and velocity of ball B changes to V2. Now let us recall that mass of an object doesn't change, so the mass is still m1 and m2. Now let's understand how the momentum has changed after collision. So for that, let us understand what was the initial momentum. Initial momentum of ball A will be the product of its mass and velocity. So initial momentum of ball A is m1 u1 and that of ball B will be m2 u2. And after collision, the final momentum of ball A will be m1 v1 and final momentum of ball B will be m2 v2. So, what is the change in the momentum of ball A before and after collision? So, we have to consider only the momentum of A. So, the change in the momentum will be the difference of the final and initial momentum of ball A. That is m1 v1 minus m1 u1, final momentum minus initial momentum. Now, according to Newton's second law of motion, we know that the rate of change of momentum of an object is equal to the external unbalanced force acting on it. So, for ball A, that is the force given by B on A, that is the force which is acting on A, will be this change in momentum for A, that is m1 v1 minus m1 u1 divided by T. So similarly for ball B, we can write FAB is equal to m2 v2 minus m2 u2 divided by T. That is a change in momentum for B divided by T. Now what did we discuss in third law of motion? We know that action and reaction are equal and opposite to each other. That means FAB is equal to minus FBA. The minus sign indicates that the force is acting in the opposite direction. So let's substitute the values or substitute the equation in place of FAB and FBA. So we have m2 v2 minus m2 u2 divided by T is equal to minus of m1 v1 minus m1 u1 divided by T. Now let's cancel the quantity T on both sides of the equation and let's open the bracket. So we will have m2 v2 minus m2 u2 is equal to minus m1 v1 minus of minus plus m1 u1. Now let's take the similar quantities towards each side of the equation. So m1 v1 will come to the LHS of the equation and m2 u2 will go to the RHS of the equation. And when they move from LHS to RHS, there will be a change in the sign. So m2 v2 plus m1 v1 is equal to m1 u1 plus m2 u2. Now if you see, m2 v2 plus m1 v1 is the total final momentum of that system which had these two balls. That is, it is a total final momentum of ball A and B which is added together. And similarly, m1 u1 plus m2 u2 will be the total initial momentum of the two balls A and B. So what do you understand from this? We can conclude that total momentum of balls A and B remain unchanged or conserved during their collision when no external force acts on them. So this is the law of conservation of momentum. The law of conservation of momentum states that for an isolated system where there is no net external force, the total momentum of the system remains conserved. The law of conservation of momentum is a direct consequence of the Newton's second and third law of motion. It is a universal law and it applies to all type of systems ranging from atomic level to astronomical level. The law was formulated nearly 3 centuries ago and till date not even a single situation has been realized which contradicts this law. In my next video, I'll help you to understand how the law of conservation of momentum can be easily demonstrated in our daily life examples. Thank you for watching the video. Hit the like button, share the video among your friends and family, and don't forget to subscribe the channel for more contents of science.